Exciting video. Grab your coffee, stay pretty, handle your business, and welcome to ByteStruct. So we're gonna solve today the problem called designing a notification system, right? So um, it's basically when you get a if I explain you in simple language, basically when you get a push notification, right, saying from your Uber driver that it's 2 minutes away, that is like a notification system working correctly, right? So when your bank texts you that they have declined your transaction alert before you even put your wallet away, right? So that is notification system working fine. Right? Even like LinkedIn sometimes pushes the same notifications to million of people in under 10 seconds delay because someone at some same company updated their job title, right? That is a notification system under very serious pressure, right? It has to span out a lot of users. So today we're going to build one that handles almost like I think 10 million, 10 million notifications per day without losing a single one, without sending anything twice, without blocking the caller for more than a millisecond, right? So stay tuned. Let's go for it. So if you go over here, right? So it's a problem where you have a let's collect more requirements, right? So you have a desktop application which is active for 90 seconds ago, with the user was online. What do you want to send him? Like you don't want to spam his emails, right? So in this case, you should have like in-app badge only, right? Push and email will be skipped because you were active user. And I think Slack does similar kind of thing. If you're active on the Slack, it doesn't send you emails about the messages and all. And it just detects if you're online. Also for mobile, right? So if it's last seen around 25 minutes ago and now you're offline, then maybe you want to push a message. And if the user has not acknowledged for more than 15 minutes, then you fall back to email. That's in general like notification. So let's understand the requirements. So most of the people dive into the problem without asking questions, right? So there are a few questions you can, mostly I think 3 questions are what I come up with. For example, which channels you want to support, right? Is it a push notification on your mobile? Is it emails? Is it a SMS you want to send? You know, they have a different reliability, they have a different cost, they have a different user experience, you know. So I think the answer to this question, interviewer might say um, that you want to support all three mediums. You want to push messages, you want to email, you want to SMS, right? So the other question is transactional or marketing, right? So I think the answer to this is both, right? So sometimes you want to send the marketing emails, right, saying we have a good deal, go and buy it, you know. And then you have sometimes transactional. So it might send you OTPs to log in, or it might send you that your money has been deducted. All of this is very time sensitive, right? So and sometimes marketing needs to be done in a bulk, right? So you will send a bulk notifications, right? So and do users control preferences? Yes, right? So they can control per channel, per category, in their quiet hours. Like sometimes they do say do not disturb, right? So all of this is, in some countries, these are like legal requirements, right? You cannot just spam users with unwanted emails, right? So this is also another kind of a requirement which you have to build in your system. Then so let's write down functional requirements, right? So usually what you do is you write functional requirements and non-functional requirements before you dive into the problem, right? So functional requirements are accept triggers from any internal service or external client. So when we are saying internal service, that means let's say somebody did the payment on your website and you want to send a notification around the payment. It's not the client interaction, right? So you want to send that your payment was successful through an email. That's like an internal services, right? So external clients are basically when you have a device itself which is sending the notification. You liked someone on the Twitter, right? So you want to send the notification, or somebody, a big celebrity, they added something on their website. You want to send the notification. So those are like a device specific, um, you know, notifications. Then we route to correct channel based on the device tokens, email, phone number, right? That's for sure. Like you don't want to send someone else message to someone else, right? So that's another function requirement. Respect opt-outs. So if somebody is saying, I don't want to get the emails of marketing, or I want do not disturb, right? So how do we send it, right? We need to check before we publish it or messages, right? So then also like track every notification, right? So you're gonna probably using some sort of a async process. So you should say, I have queued, I have sent. So at a given time, you should be knowing what your state is for a notification. So you should store somewhere. You should track it this way. Then handle bulk events, right? So a marketing campaign is going on and may target like 10 million users at once. So all of these are like functional requirements. And then when we talk about non-functional requirements, it's basically, let's say you're sending a push message, it should be under 10 seconds, right? You should not have a lot of latency. Then email should be less than 30 seconds. SMS should be less than 60 seconds. And eventually delivery needs to be granted, right? It should arrive, right? I mean, unless it's opt out, the message should be received by the user. Then no duplicates. That's important, right? So you don't want to spam your users with multiple same notifications, right? So then also like 10 million notifications per day at launch, right? So you have to build something similar to this lines. Like when we're launching, we doing to do 10 million notifications per day, but maybe we will scale it up at some point. Maybe our users will be 100 million at scale. So notification system is very common problem, and it's also complex problem given where it's being used, right? So for example, if you're using in Twitter versus if you're using on your website, but this system, the one we're building, is gonna be working with all of the different types of clients or the websites, right? So let's go. So now let's say we understand the requirements. We have function, non-functional requirements. Now our first step is like capacity classification, right? So estimation, right? So whenever we dive in, we always first start with the how much users we are talking with, right? So let's imagine you have 50 million users and they have to send 10 million notifications per day, right? That's what we are aiming for. This could increase to 100 million at some point, but right now it's the requirement is 10 million. So how would the throughput work? Like 10 million, right? So if you divide 10 million with number of seconds in a day, then you're talking about almost 116 per second notifications, right? So imagine, usually we take a big number, right? So it means that maybe you have a peak hour where your people are just keep posting like, um, like notifications, or then maybe we need 3x of peak, right? So which is like 350 notifications per second we want to send. So we're gonna use Kafka, right? So Kafka handles like 100 and like 10K plus events per second per partition, right? So throughput for us is not even a bottleneck, because if we are using Kafka, that should not be a problem. Then basically how our database is going to be look like, right? So if you have 10 million rows per day, and if you multiply by 365, it's like we're talking about, 3.65 billion rows per year. That's how much data you're going to store. Imagine each of this row is like 200 bytes, where we store ID, status, channel, timestamp, all of these parameters, right? So it comes out 730 GB per year, which is, um, you know, you can use you can use basically Postgres or some database which can help you with the storage is not like I think if you're scaling at this level, then storage should not be a problem. The only thing is you probably need a Redis, right, where you can store user preferences, how they have opted in to your website. So let's say 50 million users have preferences which are stored as 500 bytes per preference. Let's say that's the hash. So we're talking about more or less like 25 GB on your Redis. And then that's a user preference. Then what about the presence? If you want to see if the user is is it present? Is it when did it see the last message? Do we need to send the message? So all of that you can also use Redis, so you don't hit up your database. That comes up to like let's say 50 million into 50 bytes of message per message, which is like 2.5 GB. So we're talking about more or less like 25 plus 30, which is like 55 GBs, which is fitting our requirements. Then we want to talk about device tokens, right? So some context like which is used for sending messages to the clients, which is basically it's a messaging system, right? So it's a Firebase cloud messaging system which helps you send the messages. So when you download the app, it basically stores the hash key, and FCM uses that to send the messages. So you need a storage around like let's say if each user is using around 2 devices as your app, then 100 bytes per token, let's say. So you're talking about maybe 100 GB or 10 GB in Postgres, which can be used, right? So now let's dive more into this and see why this is required. So Redis again, Redis is basically to help you with the fast read. It's nothing but it's a cache which will help you do all of this, right? So let's go into step 3, which is high level design. How do we design this? So we have two types of callers, right? You have internal services where you have a payment done, your social graph, your marketing schedule, and then you have client apps, right? User is interacting with the events, which is basically they're posting, they're doing different things. So the core flow here will be, let me go here 1 second. So the core flow here is the biggest thing is notification service, right? So to begin with, you will have a load balancer, which will be talking to your internal services and your client app. That's two kind of inputs to this. And notification service job is to basically validate. It do a lot of things, right? So it validates, reads the data from the Redis, and then see what are the user preferences before even pushing the messages, right? Because maybe you have opted out, right? Then eventually, if everything goes well, then it publishes to Kafka, right? So once it's published to Kafka, your caller can be freed up. So this needs to be all in async process, right? So you don't have to hold your calling client to get 200. So you can return. So as soon as you push this to Kafka by channel, it will be push topic, email topic, SMS topic. You have 3 kind of topics, and then you return 2 or 2 to the caller, right? It's an async process, and then workers consume from Kafka, right? So you have push worker, which consumes and pushes to FCM. Then you have a email worker, which consumes and pushes to SendGrid, which is sort of an API for sending in emails. Then you have SMS worker, which will send to Twilio or other type of SMS providers we have. So once the push is done on success, DB, you need to. This is a notification DB where you will update the acknowledgement that you have sent it, and this will help also to we'll deep dive into this, but this will also help to idempotency key in Redis, right? So and then finally, when everything is delivered, you update your database with the delivered status, right? So just to show you here, right? So this is how it's going to be. You have internal service, you have client DB, you have API gateway, then you have notification services. You're talking with the Kafka, and then you have a notification DB where you store it. Then you have a Redis to figure out the preferences present, all of that. And then you have Kafka, which basically pushes the messages to different workers for FCM, in-app notifications, for email, for SMS. If you look here, pay attention. There's a fallback timer, right? So basically, this is this helps you in case of your messages are not being acknowledged, right? So for example, you send an email to push worker, you send a in push message to the push worker, and then basically the push worker will update the Redis by saying, the message has been received, right? So if it's not able to do that, right, then there's a fallback mechanism where if email has no acknowledgement, then it kind of you can retry and send it back again. We'll dive more into this, right? So that's kind of high level design. Then let's see the routing design, right? So routing here, when you look at the preferences, it's not that easy, right? So every notification runs this kind of different steps. I'm not going to go over all of these steps. You can look at internet, but basically it's going to look at if your channel is muted, or what are your notification preferences. Are they off? If someone directs you as mentioned, then maybe you want to highlight, you don't want to suppress it. What are your categories blocked for? Maybe you're blocked for marketing, so I should not send the marketing. So it's a bit complex writing your business or your notification preferences. So that's why that's also important. So going back, right? So why Redis, right? So the routing engine runs on every notification, right? Up to like 1,000 seconds per week. A DB call per notification would saturate any relational database. So it's like a cache which is. So in this problem, I think there is like four kind of four big problems which we have to address. Okay, so that's the kind of key thing here. So imagine like the first problem is we usually call it celebrity problem, right? So let's say a celebrity posts 10 million followers, right? With almost like 10 million followers, they posted something and you have to send the notification, right? So it's too much. I mean, naive approach would be just loop through 10 million users inside, one of your API call and send notification one by one. But it's not straightforward because it takes minutes and APIs can time out. So that's pretty hard, right? So how do you solve this, right? I think the correct thinking is do not do heavy work in the request thread. So the request caller, you just send them back 200 acknowledgement, and then you can basically work asynchronously. So the celebrity problem in notification system are handled in two kind of ways, right? So if your followers are greater than 100K followers, maybe you adopt to fan out on read, right? But if so first of all, like I think what we need to understand, let me show you. So there are two techniques. So first is basically fan on write. So what happens when you tweet, right? Your Kafka, you're kind of telling users, you're sending the notification. That's like we call it fan on write. Then you have a fan out read, which basically you publish the message into Kafka, and your users when they open the app, you look at where they left off, right? So if I'm following, I don't know, Rihanna or someone, right, a big celebrity, then I open my app, it's gonna look at like where did I left off, and then it will kind of pull the notifications based on if she has posted something new on her feed, right? So you can kind of that's why it's called fan out on read. So you open your app, it's going to be pretty slow because you have to catch up on all the notifications of your celebrity, uh, but this is a trade-off. So this is I think usually what most of the companies do is they if the followers are less than, let's say, 100K or something, some X number, it's a configurable number. They opt different strategies. So if it's 100K followers, they switch to fan out on read policy, right? So fan out on read can help you store event once, compute feed when user opens the app. Hybrid model, Twitter and LinkedIn run on this, and threshold can be configured. So that's one thing, right? So you're decoupling your write from delivery. You're sending users immediately to 200 and then the caller, and then you're kind of running this fan out on read or fan out on write strategy in the background, right? So that's one thing. This callers unblocks immediately, scales to any follower count, and fan out log for high follower accounts, right? So that's number one problem. Now, moving to the second problem, the duplication problem, right? So Kafka guarantees at least once, which means so there's a difference between at least one and exactly one, right? So at least once basically is used. Let's say you order pizza, right? And then, for example, if the pizza delivers to you, and then maybe for because of some glitch you got another pizza delivered to you, right? So but you will get at least once, maybe you will get second one because of some glitch. So Kafka by default gives you at least once. There's a strategies you can have also in Kafka, exactly one, but exactly one is mostly used in the transactional systems. Like for example, in banking, you want to send in money, right, to someone. You don't want to be delivered twice, right? So that's the thing, right? So how do you, in your notification system, you can use Kafka, which gives you at least once, and then you can use something on top of that to achieve exactly one. So let's see how this works, right? So push caller calls FCM, right? You got success, and you update your DB to send. Server crashes before. So imagine here. So imagine here, right? So you send the message to FCM, and somehow server crashes, right? So what will happen basically? Uh, you're committing the Kafka offset. The Kafka redelivers the same message. Worker calls FCM again. So you're sending duplicate push, right? Which is at least once, right? So maybe the system had a glitch and then you have to send it back, right? So how can we do that? Like, how can we fix not sending duplicate message? Because otherwise it's going to be annoying, right? You're getting same message. So Redis, we can use idempotency keys, right? So you have a key where you store notification ID, user ID, channel before even you send this publish to Kafka. So anytime you want to interact with Kafka, you check if it exists. If it's already sent, you don't commit, you don't publish, right? So if it's a new one, then you save to call the provider. So that's how you can use kind of a Redis along with the Kafka and store your keys there to achieve to achieve to achieve exactly once from Kafka, right? So then after some time in Redis, you can have a 24 TTL, which will delete the cache, right? So you can have up to date information. So it survives any number of Kafka redelivers, works across all channel, Redis miss after 20 years, rare duplicates. So you can have less duplicates in this case. So now moving to the third problem, which can happen is OTP stuck in the queue, right? So imagine it how frustrating it is. Like email queue fills during marketing campaign, right? And you buried your OTP message in the same queue. So user is waiting to login screen right now, but queues are, FIFO. So OTP processes after the campaign. User waits 3 minutes and closes the tab. It's like, I'm not going to log in. So we should have a priority queues in the system, not one email topic. Maybe there should be 3 email topics like priority one, priority zero, priority one, priority two. In priority zero, whenever something goes, you have those are like high priority messages, OTPs, receipts, security alerts, right? They need to be processed immediately versus P1 is like your social friend requests, likes, which can have like a delays that should be okay. Then email worker always drains P0 first. P0 should be the nearly empty at all times. That is the design goal. Keep P0 small. If everything qualifies for P0, nothing does, right? The critical notifications never wait in line, simple to implement at Kafka. Every call site must assign the right priority. So to achieve this, I think you can have multiple queue systems embedded in your system, so it can help. That's the number three. And now moving to number four, sometimes providers break. Like you're calling external system like FCM and stuff, right? So not all FCM errors mean the same thing, right? So if you send FCM 429, that means you have exceeded the rate limit on their side. So you might be calling, you were supposed to call 30 APIs per second. You're calling maybe 50. So you have hit the rate limit. So exponential backoff needs to be there. You should try maybe after 1 second, 2 seconds, 4 seconds, like exponentially at max like 5 minutes. And then you can have an error queue where you can store your data. If FCM is sending you 410 and 404, that means invalid token. So the token, how it works is like once you have a token in your app and then you delete the app, right? Then that token is no longer valid. So if you get this message back, do not retry. So device reinstalled or revoked, delete token from Redis and DB immediately, right? So you don't hit up into this loop where you keep calling. Retrying wastes quota, FCM throttles your key, right? These are expensive. FCM 500 server error, you can try it some like maybe 3 times, and after that you push that message to your DLQ where your support team can check and re-trigger the message, right? DLQ is a health signal, not just a graveyard, right? Flat DLQ depth, a healthy system. Growing DLQ provided outages, auto failure, so we can have some type of secondary providers. For example, for email, I mentioned SendGrid primary. Then maybe there could be a AWS SES fallback, right? Or SMS, you can have Twilio, or maybe you can use SNS fallback. So you can have a different providers like here, right? So you could have FCM, SendGrid, SES, Twilio, or SNS, right? So you can have all these providers as well. So that's number four problem. I think systems should survive during outages with follower mechanisms. And now talking about the trade-offs, right? So we said fan out on write versus fan out on read. So that's one of the problem we have solved, right? So if your celebrity has more followers, then you opt out fan on read, right? In that scenario. Twitter and LinkedIn run this model, and threshold is config value, not a constant. Interviewer is testing you. Do you know this is not a binary choice, right? So it can be depending on the number of followers you have. At least once versus exactly once. We talked about it. Kafka gives you at least once by default. True exactly once. Kafka transactions plus atomic DB commits, independent producers, right? So you can all achieve this. You can store it in in Redis your independency keys, and then you can use that. Synchronous versus asynchronous. Asynchronous is the default for scale, right? But there is a trade-off in cases of OTPs, right? If delivery fails, surface that failure now, right? So asynchronous Twilio call gives you that. So I think in synchronous way, you can use maybe your OTPs, right? That could be your exceptions, and Twilio gives you, right, with less latency. And for everything else, you still choose asynchronous way, like social marketing and other things. um, Providers, right? So providers can have outages, right? So no fallback, like FCM APNs are proprietary, queues and waiting down. Emails, you can have SendGrid as a primary and then SES as a secondary, Twilio as primary, and then again AWS SNS as SMS as a secondary. Monitoring, right? So delivery rate per channel, alert below 95% for push. If things are piling up, then we should have a monitoring system which can help you in having a less number of outages, right? So that's another one. Now, basically, when we do like things like synchronous transaction notification with strict delivery guarantees versus asynchronous for everything else, that's the key, right? So notification systems are a building block. They show up as a subcomponents in Twitter, LinkedIn, Uber, Slack, and other places. Almost every large system design question you will face this, right? So you should know the code, right? So basically you should know like what are the hard problems, so you should be discussing that with the interviewer. Yeah, and with that, I'm gonna wrap this up. And if you have any questions, add to comment. We can chat. And thank you so much. We'll see you in the next one.